Hi, this is Sumin Han from Geology Lab in KAIST. Today I'm going to tell you about hydraulic fracture propagation in gelatin. Conventional oil and gas is easy to produce with a vertical well. However, conventional oil and gas is more difficult to produce. To increase the productivity of oil and gas wells, two techniques are used: horizontal drilling and hydraulic fracture to create extensive artificial fractures around well bores. The design of hydraulic fracture requires the geometry prediction of the induced fractures, and it was predicted by the pressure curve obtained from field. Thus, the hydraulic fracture propagation experiment was studied to get the answer of these three big questions. Question 1. What is the geometry of generated fracture? Question 2. What is the fracture behavior at discontinuities? And question 3. How does stress distribution change at the fracture tip at the discontinuity? To see the geometry of generated fracture, hydraulic fracture propagation behaviors in gelatin plates were monitored. Gelatin was used to represent the rock because it is homogeneous, transparent, easy to control the stiffness, and has photoelastic property. To conduct the 2D experiment, gelatin mold with thin thickness was made. At the center of the gelatin plate, a copper tube having two vertical holes was inserted. Through these two holes, the fracture fluid was injected using pump to create hydraulic fractures. Then we can measure the fracture length and width, then compare with the pressure curve obtained from experiment. Also, using the photoelastic property of gelatin, the stress intensity factor that described the stress distribution at the crack tip was obtained. The same experiment can be conducted with different stiffness of gelatin, viscosity of injection fluid, and flow rate of injection fluid. To know the fracture behavior at discontinuities, gelatin plate having discontinuities were used with different level of stiffness. In this case, the hydraulic fracture generated and then propagated to the discontinuity. Then it can go through the interface, or dilated, or arrested. The fracture length, width, pressure, and also the stress intensity factor can be measured as well. The stiffness of bounding layer, induced fracture incident angle, and distance between borehole and discontinuity can be controlled. Thank you for watching this video.